From the title, seems like a very, very detailed, very techy presentation, and there will be certainly some elements from that. I understand the audience is pretty broad here, but there's a broader message that I hope comes through, and I'll try to make sure that I hit those points. I am with Chevron, retired as of December 8th, after 35 years. So I was Chevron's wireless technology lead, and I couldn't turn it off when I retired, so I kind of want to keep the wireless thing going, and particularly something that I kicked off when I was there within industry about gas sensing. So hopefully you enjoy it, and get used to the control here. Okay, so we'll talk a little bit about, excuse me, why to consider wireless, excuse me, the ease of deployment of wireless devices. I want to talk about some definitions of what wireless is. Everybody thinks of wireless, this is this. Probably a lot of people here are not familiar with instrumentation and stuff, so I'll talk a little bit about that, just to set the groundwork here. Some applications, lessons learned, the gaps that we encountered when I was at Chevron, and why wireless gas detection I think is really fundamentally important. And I'll talk about some of the initiative processes that I kicked off there in industry. So I just put a slide in. Chevron is a multinational energy company. We have oil and gas production worldwide, refining, chemical businesses. The use of wireless in that business is for a whole bunch of things. Again, this current generation of wireless, I would say, really developed in the mid 2000s, 2005, something like that. And the key places it was used initially was for older facilities that we needed to get more analytic data into our systems. We're using it, they use it more for process equipment, monitoring process equipment and processes, improve asset integrity. And I'm really going to focus on this piece of asset integrity. That's the big message I hope to leave you with. So we're going to talk about some minutia of wireless, not too techy, but I want to give you this big piece that gas detection is a new and developing technology for asset integrity, leading to operational excellence of your facilities. And then another thing that we did was a lot of greenfield projects were coming out from engineering teams, going to construction, going to operating teams, and all of a sudden there were a number of things that they felt the design engineering people left out. Another key aspect of wireless technology that we used. So why consider wireless? It's easy to deploy. Probably you look at the cost of a wireless device, and you say what's more expensive than a regular device. So let me for you guys who are not instrument people, we're talking about a small thing here. I'll make a definition. A wireless device is maybe a little bit bigger than the phone and can take some sort of measurement that is of interest to the process people, or interested to people that want to know what's going on in ambient air in a facility. The cost of installing wired devices in facilities far exceeds the cost of the individual wireless device. So it's, one of the reasons the ease of deployment is really the reduced engineering time and the construction. An example of putting a wireless device into service, instead of all this engineering required, is to, there's no pointer here, is there? You provision the device, you get the device, you open it up, you provision it, which is basically giving it security information. You install it in the field location to make the measurement. You power the device, allow it to find the network, and you complete a provisioning to complete the security process. The more sensors that are deployed in a facility, in a refinery, in an upstream processing facility, the stronger the wireless network becomes, because they're all communicating with each other. And you think more devices are going to be bad. In more devices in this sort of industrial wireless space means a stronger, broader network. And then another reason to consider using wireless is difficult locations. There's new things coming out, have come out. in sensing other than the normal pressure level, temperature, and flow. And we'll talk a little bit about that. But we're now putting in, people want measurements. Process people, safety people want measurements of things in areas that we never thought of traditionally with instrumentation. So that's a very key part of enabling the sensing in difficult and non-traditional locations. A definition of wireless. It's not a cell phone, but it's small. I always have to put this in there because so many people have different ideas of what wireless means. But I'm talking about something that's probably roughly the size of 4 coffee cups, if that rings a bell with anybody. It has an onboard battery inside. It's not a big battery sitting on it's not a big battery bank sitting on the ground somewhere. It's enclosed in the device. Battery life of approximately 5+ years is a criteria that generally industry has accepted for this. It's based on a standards-based protocol for the radio and the transmission protocol. Generally omnidirectional antennas, so at least my frame of reference here is not necessarily having wireless between 2 remote points, like separated by 5-6 kilometers or something like that. I'm talking about relatively short distances and RF energy being broadcast multiple directions. The key requirements that I found are these devices. There need to be an onboard processor for characterization of the different types of sensors, whether it be a gas sensor, a pressure sensor, a corrosion sensor. I think Larry referred to in his introduction, the lower level is smart sensors. These are smart sensors that have, their signal is enabled through RF technology. There's no other wired connection to them. The only other connection is a process connection to whatever you're trying to measure. So there are sensors involved. It's important that they're interoperable with industry standards, including things like gateway functions, that's kind of a techie thing, and asset management software. We don't want to have proprietary stuff that doesn't play well with other things. It needs to have easy wireless network management, good diagnostics, simple sensor calibration. Particularly, we'll talk about the gas sensor part here in a minute, and of course safety. These essentially really are never sure where these things are going to end up in the field, to have a Class 1, Div 1 capability. What I would characterize existing wireless applications are certainly the basic pressure level, temperature, and flow, equipment vibration, and temperature monitoring of equipment, whether it be pumps, compressors, the piping in equipment, corrosion, erosion, something that's probably really developed in the last 3-4 years maybe, getting more and more sophisticated. Work still needs to be done in that area. Discrete input monitoring, access to stranded diagnostics, a big one, used through a lot of industry people that have devices in the field. They're probably wired devices, but they have a control system that's old. They don't have any way to extract the diagnostics out of that device. So you can put a wireless device on that wired transmitter and get diagnostics through the RF system. Acoustic monitoring of steam relief systems, again, a relatively new thing. I would also characterize that as a developing technology, and valve position monitoring. An area that I was particularly interested in when I left Chevron, and I still have a lot of passion around, is the idea of chemical sensing. The first ones are a little bit more difficult, maybe. Chemical sensing, and you can see hydrocarbon in water, selenium in water. These are measurements of some properties in a fluid stream, or possibly even in groundwater, possibly. That's a developing technology. Ambient gas sensing, which is the one I've got a lot of passion around, and will be kind of the culmination of this presentation. And toxics, things that exist in our facilities, may exist in our facilities that we don't want to be there. We want it to be inside of things and not in the ambient environment. Toxics, combustibles, sulfur compounds, volatile organic compounds, and others. The lessons learned for the broader wireless space throughout my career with Chevron and dealing with wireless and in industry, I think, is Data security is paramount, and I'm sure you've heard a lot of things about security here. It's my belief that through the standards organizations, through the common work of suppliers and the users, I think they're completely robust. There are certain facets that you can choose to implement. If you choose all the features of security models, they're very solid. That was probably the biggest barrier when I was at Chevron of using wireless, was this idea of connecting wireless things to the control systems that are controlling our refineries and our processing plants. We really had to spend a lot of time on that security piece, and I think we've got it. Educating internal customers. Chevron, when I was there, I was in the technology corporate group, but I had to go out and sell to everybody. And I had to go to each plant individually, talk to them. And there was some early adopters of technology, mostly in the late 90s, that really gave a bad taste in people's mouth about wireless sensors. And some people just don't forget about that. And I had to do demonstrations and pilots to get them past that. Left a legacy of distrust. The application should be, again, lesson learned, the application should be consistently use of wireless. Wireless for control, as I was leaving Chevron, was just something that's being investigated. Certain suppliers of equipment out there will suggest you're ready to go for wireless for control. It's my opinion that there may be some applications that are okay, but that's something you need to consider for wireless. It needs to be plug and play, just needs to work when you go through the proper procedure. Should be no difficulties in getting the system to operate, and they're very robust and easy to use. Should work in a harsh industrial environment. And then the 2.4 gigahertz. A lot of people had concerns about, and I had initially had concerns about putting radios in heavy steel environments. Say, let's take an offshore platform, for example. We installed a system off the south coast of Borneo offshore, and it was a relatively large facility, had solid steel decks on the platform. I was very concerned about the RF propagation through a solid steel facility like that, particularly with the solid decks and the data getting from deck to deck. We had absolutely no issues with that. I don't know, we speculate that the energy re-radiated off the deck into the next deck, not sure. It's a bit of magic, but it works. So again, this is sort of the thing that comes up in my internal customers, although it never worked in an industrial facility, but we've crossed that bridge and it's absolutely fine. But the gaps I found were that there had been a lot of work done on the battery radio combination, making it small. Cell phone technology certainly made radios small. Remember, it used to be the big cell phone we used to use. Everything shrunk down. We got it to the industrial side. The problem was the sensor piece. That didn't keep up as fast. Developing of sensors that were compatible with low power wireless operation did not catch up. And there's reasons for that. So that was a gap that I identified. Optimization for more advanced facilities, applications, for like things like vibration corrosion. That was a gap that continues today. And continued development in the ambient sensing, again, the ambient detection of gases. So why do wireless gas detection? So I said I wanted to get, so that was a little bit of techie stuff. I want to get back to the big picture here. So what I'm trying to do, what I think is important, is we go to a lot of effort to select piping, select things that won't corrode. We do have some tools now to monitor for corrosion of piping. We have some wireless tools. Those are all to make sure that our assets have strong integrity and we execute good operational excellence. To me, gas detections are the next extension of that. If we develop leaks here and there, a flange leak, a corrosive spot that's under insulation that you can't see, it's my belief by having wireless gas sensing that are small, that are competitively priced, that we can put these everywhere, not only on a ground level, but picture a 3D model. If this was a refinery that we're standing in here, I picture these gas sensors, depending on the types of gases, but they can deploy it throughout the network. And if you've already got sensing for processes or equipment, by using industry-based standard devices, they just join into the same system, and you can paint this 3D picture of what's going on in your facility as far as gas releases, and use that for an operational tool along with your other corrosion monitoring, your process sensing, to give you a complete picture of the asset. That's, I think, my message in a nutshell. IoT, Industrial Internet of Things, more analytical tools needs, from my perspective, needs more data. Certainly there's a lot of data on things that are mined, but things like corrosion for asset integrity in a lot of facilities are a manual operation currently, and they're manually taken once a year, maybe if you're lucky in some facilities. It's just ripe to get more devices out there, more information coming in, applying analytical engines, pulling all this data together to see what's going on with your facility, make sure it's safe, make sure you're meeting your operational integrity targets. Another reason why gas technologies can provide accurate, broad picture of what's going on. Again, I should have said they got 3D. So I've been doing all the wireless stuff. I saw these gaps, and I kicked off a process within Chevron when I was with Chevron. I don't speak for Chevron anymore, but at least the time that I left. Before I left, I had an initiative, and it was to look at developing an H2S and a methane sensor. And it needed to be, again, methane, H2S will be the first one that I think that I pursued, because the sensor technology, there were some technologies out there that were somewhat compatible with wireless operation. So that was the easier nut to crack. The other one that's very interesting to me is methane. Traditionally, methane in its wired form is generally a power-hungry type of device, or there's other technologies out there that don't give you as much detailed information. My initiative, I wanted something that was 62591 compatible, wireless HART compatible. It needed to be, not require work permits. In the early days, that was a real barrier to wireless devices. You put it out there, that was all nice and good, but then you had to go change a battery, you had to go change a sensor, and all of a sudden, if you're in a facility that requires a lot of processes, like a refinery that we had, it was an act of Congress to get a work process in place to go out and do that. That was a real barrier, because the guy said, hey, this is not working. This is supposed to be cheap, an easy way to put it. So that was a key criteria for me. One-button calibration is certainly something for the gas sensing part, since you need to be there and put gas on to do the bump checks, and that needed to be in place. LCDs display to make it easy to do that, to operate the device and to check the device. And again, back to the 5-year battery life criteria. So my approach to this was I was able to get some seed money from Chevron to give to industry. There was no ties back to Chevron. So I went to industry to find a way to accomplish this task. And we thought that because I couldn't find an existing product to meet my criteria, I got some money, went out and did this. We worked with some suppliers, and we initially worked with a company called ISS, Industrial Sensor Systems. This was, I said 3 years, that was probably at least 3 years ago that we started this concept. It's taken a while to get there. More recently, United Electric has joined it, and so we've kind of we've got at least a prototype unit that has come out of that effort. The advantages I saw of using an effort between Chevron and the industry was that I was hoping to accelerate the product to market, and when UE came into the mix here, that's happened very quickly. That really was very nice. We had able to identify problems really fast. An example on the fast problem identification, when I was working with an industry partner, it was a very dynamic, very sharp company that we would identify problems one day, and within a week we had fixes. They'd bring product to me. I said, no, that's not quite right. So I thought a real advantage to the co-development process. And they brought a lot of innovation. A lot of things about how the display operated, how to get the power down, because that's the name of the game in wireless devices. And I think it gave us the right product at the right time. It helps accelerate that. So, so my message is, if I missed it, if I missed you in the techie talk, was that I think that we can have a better picture of our asset integrity, our operational excellence of facilities, eliminate incidences, eliminate fires, and worse things by having a comprehensive wireless system. And I think the gas piece is something that's is really now being addressed, and I think it's going to be real helpful to our industry. So thank you very much.